Hello, this is Mr. Precella, and we're continuing to work on our review sheet for our third test in my face-to-face college algebra class. And we're up to problem number 10. Let me write it down. Log base 5 of x equals negative 2. Well, in order to solve an equation, ultimately you've got to have it in the form x equals some number. You just want to x equals, in fact, it's going to be one of these numbers here. Okay? So how do we get that x by itself? So we're still isolating the x. Well, we somehow need to cancel out that log base 5. To do that, we're going to use one of our rules of logarithms, which says b to the log base b of x. If you have the same small number and big number, all of that cancels out, leaving you, in this case, x. So what big number do I need to put on both sides so that I can cancel out this log base 5? Well, a 5. If I put a big 5 on each side, all of that cancels out, and be careful, you have just x on the left, and on the right, don't say negative 10, it's 5 to the negative 2 power. How do we simplify a negative exponent? Well, a negative exponent means 1 over. Okay? So 5 to the negative 2 power would be 1 over 5 to the positive 2 power, which is 1 over 25. 1 over 25, answer A. Now problem number 11, use the change of base rule. The change of base rule says this: log base b of x is equal to log x divided by log b. Or if you want to use your ln, your natural logarithm key, that'll be fine too. I think I'm going to use log. So on problem number 11, let's write it down. There's number 11. Log base 5.8 of 2.6. Well, my calculator doesn't have a log base 5.8 key, but it has a logarithm key and a natural logarithm key. I'm going to use just the LOG. Change of base. You've got to remember that the subscript is the number you put on the bottom. The number that's written lower is the one that goes down. So it'll be log 2.6 over log 5.8. Now, most calculators, when you hit the LOG key, it opens parentheses. Mine, it does that, so I've got to be sure to close them. Okay? Now, normally I have a TI 83 or 84, but that doesn't show well on here, so I'm using a calculator on my phone. But for test purposes, you shouldn't be using your phone for this. You should have a normal calculator. I'm just using this because it shows up better. I'm punching in log, notice how it opened the parentheses, 2.6, close the parentheses, oops, then divided by log. Hey, this calculator does have an ln key. If you want to use that, that's fine. Square root of 5. On this calculator, if I don't close the parentheses at the end, it still gives me the correct answer. Oh, wait. I think I punched in the wrong numbers. I'm not going to stop the video and redo it. Let me do it again. I'm punching in log 2.6. I think I was looking at the next problem when I put up that square root of 5. Divided by log 5.8, close parentheses, equals 0.5435. Looks like they're rounding it to 4 decimal places. So 0.54356, so that would be a 6. 0.5436. Answer choice D. Okay, so D. This change of base, it goes log over log. That's where I got the square root of 5. Look at number 12. Number 12 says log base square root of 5 of 183.3. It's log over log. The number that's written lower, the subscript, that's the one that goes in the bottom. And pardon me, watch your parentheses. And let's see, here I am punching in log (183.3) close parentheses divided by log square root of 5. Theoretically, there's I should close those parentheses there at the end, but if I don't, it'll still give me the correct answer. 6.4757. 6.4757. Let's see, which one is that? D. So that's the change of base formula, log over log. Or if you want to hit the ln key on your calculator, that's fine also. It'll get you the same answer. Just don't mix it. Don't hit log on top and ln on the bottom. No. Problem number 13 says f of x is ln x. Ooh. Find f of e to the 17 ln x. Well, with function notation, this means plug all of this stuff in for x. So we have an ln, and then we have an e to the 17 ln 23. Well, what's that rule about e and ln? When they're side by side, they cancel each other out. So there, leaving us with just 17 ln 23. Oh, let's see. That's another D. Okay. Now, we're going to start expanding logarithms. Okay. When you're expanding logarithms, if you have a radical, you need to first write it with fractional exponents. So, like right here, this 5th root. We said in class that just reviewing something. A square root is the same thing as a 1/2 exponent. A cube root is a 1/3. A 4th root a 1/4, and so forth. 5th root is a 1/5 exponent. So on problem number 14, the first thing we should do is right that the 5th root of 17th of 17 is 17 to the 1/5 power. Okay. And then you're going to expand them. But to expand logarithms, you separate them at multiplication and division. So I'm separating it here and here. The exponents will go in front of the letter L. So we're going to have 1, 2, 3 logarithms. For this first one, the 1/5 will be in front of the letter L. Also, the stuff on top has pluses in front of it. The stuff on the bottom has minuses. So there should be 2 minuses. And I'm just going to write out the answer now. The way we did in class. 1/5 log base 8 of 17. Moving to the bottom, it's moving to the y, it's on the bottom, so minus 2 log base 8 of y, and then a minus log base 8 of x. So look closely, very, very closely at these options. I'm thinking it is C. Okay? Remember doing this condensing, and expanding. Right here, we'll first rewrite each one of the radicals. Like a cube root, you would write it with a 1/3 exponent. A 7th root would be a 1/7 exponent. So we have m to the 1/3, n to the 1/7. And now let's expand it. You separate logarithms at multiplication and division, not at addition and subtraction. The exponent goes in front of the letter L, so I'm starting with the m. 1/3 log base 5 of m plus 1/7, plus because the n's on top, log base 5 of n, then a minus because the k is on the bottom, 2 log base 5 of k. But it's definitely not A, which has multiplication and division symbols, or B. Okay? They should have those multiplication dots or division. Is it C? Thinking it's C again. Say again because the one right before it was C. Number 16. We need to rewrite it. Log 7x squared. This cube root I'm going to write as a 1/3 exponent. And now let's see. Where do I separate? I separated at multiplication and division. I remember this semester the student told me she didn't understand why I put those red dots, but she can tell that I seem to think it's important. And I was like, yes, it's very important. That's where we separate. We're not going to be separating at addition or subtraction. This x plus 1 has to stay all together as x plus 1. Same thing for the 1 minus x. You separate at multiplication and division. And now I'm ready to, so I'm going to separate it into 1, 2, 3, 4, 5 logarithms. So there's not an exponent on the first one, so I just write log 7, then a plus, because it's on top, 2 log x. Notice how you put the exponent in front of the letter L. Then another plus, 1/3 log 1 minus x. Exponent in front of the letter L. Notice how the 1 minus x stays all together. Then move to the bottom, minus log 4. And then a minus 2 log x plus 1. You might be thinking, well, Mr. Precella, it looks like you're just writing down the problem and writing down the answer, and that's what I'm doing. Okay? Not a lot of work that you need to show to get these. Oh, wow. Glancing through this, I don't know if you can tell, but those are division symbols there. So it's definitely not C. That's a multiplication dot there, and they're definitely not A. It's B or D, and it is B. Okay. Now in algebra, you always do it one way, then do it in reverse. That's true for all math. Like in calculus, you differentiate, then you anti-differentiate. In algebra, you learn to FOIL, then you factored. Here, we were first expanding. Now we're going to go backwards and condense. In order to write this as just a single logarithm, use the properties to condense. I'll write it as log base b. And the first thing I always ask myself when I'm writing a single logarithm is there going to be a fraction? And the answer is yes. Because of these minus signs, there'll be a fraction bar. The stuff on top, remember the number in front of the letter L is a exponent, so it's going to be q to the 5th on top. Now the r is on the bottom because of the minus, but there's not an exponent, so just a r. The a is on the bottom also with no exponent. A. Do not choose this answer. It should be r times a, not r minus a. If you think of this rules of expanding, if you were trying to expand that, you couldn't separate the r and a. Why? Because you separate at multiplication and division, not at addition or subtraction. So this one would be C. Now what about number 18? Well, condensing it down to just one logarithm, first thing I do is ask myself, will there be a fraction bar? And the answer here is no. Why am I saying there's not a fraction? Because of this plus here. If this plus had been a minus, then we would draw a fraction bar. But there's no fraction bar, so just write down, remember this number in front of the letter L is the exponent on 4, so we have 4 to the 3rd and a 2. What's the operation going on here? Well, times. Don't put a plus. If you put a plus there, then it couldn't have been separated. Well, this answer isn't listed because why? Well, we can go ahead and let's use our calculator, or if you want to use the calculator in your head. 4 to the 3rd, 4 times 4 is 16, times another 4 is 64, times 2, 128. So C there. Now let's see, we have time to do a little bit more. Continuing this condensing of logarithms here on problem number 19. That's an LN. A lot of times students think it looks like an IN or a 1N. Here it's not a problem typing it in because it's just paper, but realize on my math lab when you're typing it in, make sure you're typing an L, not an I. I've gotten dozens and dozens of questions from students over the years telling me, oh, my math lab messed up, it counted it wrong, when they know that it's right. And I look at what they've typed and I'm like, logarithms begin with L. That's a lowercase l, not a capital I. In general, on my math lab, you should never type a capital letter. So, to condense this, it's Ln. Because of this plus, if that plus had been a minus, it would be a fraction bar. But here, there's no fraction bar. And we write x and then y to the 7th. The 7 is an exponent on the y. Do not put a plus there. Okay? It is x y to the 7th, not x plus y. This thing here can't be separated or expanded. Okay? This is the one that can be expanded. Why? You separate at multiplication and division. Oh, let's see. What about this one? Log base 4. Well, is there a fraction bar? Yes. Because of this minus, there's going to be a fraction bar. So the number in front of the letter L is an exponent. So we have a 2 to the 3rd. The number in front of the letter L is an exponent. So we have r minus 6 to the 1/7. The number in front of the fraction bar is an exponent. So we're now down in the bottom because of that minus. So it's going to be an r to the 1/2. None of the answers look like that. We need to do a little bit more work on this. 2 to the 3rd. 2 times 2 is 4 times 2 is 8. Now going back to what I was saying about what these fractional exponents mean. A fractional exponent means a radical. So this 1/7 exponent is a 7th root. This 1/2 exponent is a square root. And there's only one answer choice as a 7th root and a square root. It's got to be this one. Answer choice A. Now, problem number 21. Let me get a clean sheet of paper here. It says, solve the exponential equation. Express your solution in terms of natural logarithms. Well, heck, that gives you a pretty big hint there. You might recall in the homework, some of this stuff was really messy punching it into your calculators, like number 24. But here we stop. We don't have to punch in the calculator. So 21. 8 to the 4x equals 3.4. In order to solve this for x, you stick a ln in front of each side and then simplify. With the ln here, that lets us carry down the exponent. So we'd have 4x ln 8 equals ln 3.4. Notice I'm using a capital L, so it doesn't start looking like a 1 to you. Now this one, to solve for x, we're just going to divide. There's only one x in the whole thing, so just divide both sides by 4 ln 8. And there it is. ln 3.4 divided by 4 ln 8. No, I was about to say it's A, but no, it isn't. That's 8 ln 4. You got to look really closely at these. Pay attention. C. Okay? You should get a good night's rest sleep before you take the test, because you got to be awake. Even if you can do the math, you got to be paying attention to C. A, B, C, D, they all sort of start looking the same. Now, problem number 22. E to the 4x equals 7. Well, this one is actually going to work out really nicely, because when you stick the ln in front of each side, we have a rule about E and ln. When they're side by side, they cancel each other out. All that we have left is just 4x equals ln 7. How do I solve that for x? Well, divide by 4. They can't all be this easy. don't worry, problem 24 is common. So ln 7 over 4, that is A. Now, number 23. Oh, it's another one that has an E in it. Good. E to the x plus 4 equals 2. Why did I say good? Those are the easier ones because E and ln have that property where they cancel each other out when they're side by side. ln is log base E. E is that decimal number, approximately 2.718281828. Are you going to do anything with that 2.718281828? No. What are you going to do? Cancel the ln and the E, and you have another little equation that's not that hard to solve. How do I get the x by itself? Well, subtract 4. So we have x equals ln 2, subtract 4 minus 4. Do you actually subtract the 2 and 4? Oh no. Okay? If you wanted to write it negative 4 plus ln 2, that would be fine. I'm thinking the way it's written here is that ln 2 minus 4. Notice it sure looks like IN or 1N, but it's an L. Now, problem number 24. They can't all stay that easy. These were the ones that for the homework, having to punch it in and get that decimal number was sort of tedious, watching those parentheses and so forth. So, fortunately, we don't have to do that. We don't have to punch it in to a calculator. So this is 4 to the x plus 4 equals 5 to the 2x plus 5. Well, stick ln in front of each side and carry down the exponent. Okay, so stick ln in front of each side and then use that power rule which says you can carry down the exponent. So we'd have x plus 4 ln 4 equals, carrying down that exponent, 2x plus 5 ln 5. Now let's try to solve for x. This is where it gets a little messy. You're going to distribute the ln 4 and the ln 5. But you're not actually going to multiply any 4s together or get 16. All you're going to do is treat it as if you were just distributing a variable. You just go x ln 4 plus 4 ln 4 equals 2x ln 5 plus 5 ln 5. Don't get any 25s or 10 or something. Don't start multiplying those numbers. Now, since there's two different x's, we need to move this stuff around. Let's isolate all the x terms on one side. So I'm going to, use my little arrows, I'm going to subtract 2x ln 5, and I'll subtract 4 ln 4. So, keeping with the colors, here's what we have. X ln 4, I'm moving that 2x ln 5 over here, so minus 2x ln 5 equals, moving the 4 ln 4 over here. You're not going to get 1 ln 1. It's 5 ln 5 minus 4 ln 4. I'm saying ln for natural logarithm. Now, we have the 2x terms on the same side. So we isolated the x terms on one side. Now we need to write it with just one x. The way we do that is by factoring that variable x out of there. If I factored that purple x from each one of these terms, what would be remaining? If I just covered up the x, I'd have an ln 4, then a purple minus 2, ln 5. Okay, so taking this x and that x out, if I distribute that x, I should have what I have there, which I do, equals, and over here I'm going to stop using different colors, just write it, 5 ln 5 minus 4 ln 4, with one step left to do. If I want to get that x completely by itself, in order to isolate that x, I have to divide both sides by ln 4 minus 2 ln 5. ln 4 minus 2 ln 5. And then look very closely at the answer solutions. It'd be terrible for you to get this far and then choose the wrong one. Let me see. Is it B? I'm thinking it's B. Looking at the bottom. ln 4 minus 2 ln 5. The only thing that is ln 4 minus 2 ln 5 is problem number, is answer choice B. So 5 ln 5 minus, yeah, B it is. So to solve this exponential equation using natural logarithms, you stick ln in front of each side and carry down the exponents in front of the letter L using the power rule of logarithms. Distribute. Move the stuff around so the x's are on the left. Factor that x out and divide. Okay? Now, let's move on. We're solving some logarithmic equations now. And to solve logarithmic equations, you've got to have the equation in the form. Your goal here is to write it with a single logarithm equals a single number. So on 25, you have two logarithms, equals a number. So what we'll do is try to write it with just one logarithm. How do we do that? We'll use those condensing rules that we were using for problems 17, 18, 19, 20. To condense this logarithm, I ask myself, will there be a fraction bar here? And the answer is yes, because of that minus. So there's a fraction. The x plus 5 goes on top. The x plus 3 on the bottom. And if we want to solve this thing for x, that means we got to get rid of this log base 4. Well, whatever this small base is, if you put a big base like that on each side, that'll cancel out the logarithm. And it leaves us x plus 5 over x plus 3. Now be careful. This is 4 to the 4th. Don't say 16. 4 to the 4th. 4 times 4 is 16, times another 4 is 64, times a fourth 4, 256. I'll write that as 256 over 1 and solve this by cross multiplying. So we'd have 256x plus 250 times 3. That's going to be 750 plus 18, 768 equals x plus 5 times 1 is just x plus 5. So now a linear equation, isn't it? So just isolate the x. Subtract 1x. 256 minus 1x is 255x. And 5 minus 768 is a negative 763. Divide both sides by 255. Negative 763 over 255. I was about to say it's B, but no, it is D. Okay. So if we're going to write or solve a logarithmic equation, you've got to have it in the form 1 logarithm equals a number. So if you have 2 logarithms on the left, condense it down to get 1 logarithm. On 26, we have logarithm equals 4 plus logarithm. Well, darn. We need both of the logarithms on the same side, like number 25. So using that old problem-solving strategy, if you know how to do one type of problem and you're confronted with a new one, make it look like the other one. So I can make number 26 look like 25 by subtracting log base 2 of x minus 2. So we'd have log base 2 of x plus 3, then a minus log base 2 of x minus 2 equals 4. Now it's very much like number 25, isn't it? Well, let's condense it down. I always ask, will there be a fraction bar when I'm condensing it to 1 logarithm? And the answer here is yes, because of that minus sign that I just circled. The x plus 3 is on top. The x minus 2 is on bottom. And now it's in the form logarithm equals number, so let's cancel out the logarithm. How? This logarithm base is a 2. Let's put a big 2. That'll cancel it out. And we have x plus 3 over x minus 2. Don't say 8 equals 2 to the 4th is 16. Oh wow, this one is very similar to number 25, isn't it? Now cross multiply, so we have 16x minus 32 equals x plus 3. So subtract x, 16x minus 1x is 15x. 3 plus 32 is 35. Divide both sides by 15. And you might think, well, wait, that answer's not listed. Well, let's see. Can we reduce 35 over 15? Dividing each of these by 5, what are we getting? A 7 over 3. And that answer certainly is listed. D. Right. Now, problem number 27 has some, there's going to be a pretty large number. You'll probably want a calculator for this one. Problem 27. It's logarithm equals 3 minus, well, we better move this logarithm over. We know what to do if there's 2 logarithms on the left. You condense it down. So I'll move log base 35 of x over to the left. And now I'm going to condense it down to just one logarithm. I ask myself, will there be a fraction bar? And the answer is no, because of that plus sign. If this plus sign had been a minus, then yeah, there'd be a fraction bar. So we'll write this as just x minus 70 times x. I think I'm going to put the x right there in front. And here's where we start to get some big numbers. To cancel out this logarithm, I've got to put a big 35 on each side. So on the left, I just have x squared minus 70x. And pulling up my calculator, what is 35 to the third power? Let me see. Again, I'm using a calculator on my phone just because that's what shows better under here. 35 raised to the third power. It's going to, oh, big number, 42,875. Well, fortunately, this is a multiple choice test, so we'll sort of take advantage of that as we go through this one. I'd move the 42,875 over because this is a quadratic equation. There's an x squared in it. So to solve a quadratic equation, I either factor or use the quadratic formula. Looking at the answer choices, it has to factor, okay, if we're going to have integer solutions like that. So rather than listing out all the numbers that multiply together to give 42,875, that's how I would normally start it if the number was smaller. But let's see, looking at that answer solution, let's divide 42,875 by 175, and here's one possibility. 175 times 245, let's see, 175 times 245 is 42,875. So that's two of the numbers listed here. I bet the other two also multiply together to get 42,875. Let's see. 25, oops, let me clear that. I never use this calculator. There. Okay, 25 times 1715. Those are the other two numbers that were solutions. Yeah, so there's the only two pairs of numbers I need to concern myself with as I try to factor this stuff. See, it would be a much harder problem if it weren't multiple choice. So which of these pairs will work? By work, I mean give me a negative 70x. It's going to have to be 175 times 245. And in order to get a negative 42,875, second sign is minus, so 1 plus 1 minus. To get a negative 70, we have to arrange it like that. So I factored it, and now set each factor to 0, and we get x equals negative 175 and positive 245. Now, when you look at the answer choices, you might be thinking, well, wait, there's not two answer choices listed. Well, remember, you only want to have, you can't take the log of a negative number. Negative 175 can't possibly be a solution, because if it were, we'd be taking log of a negative. Right up here. Be sure to reject any value that's not in the domain of the original logarithmic expression. So we knock out the negative 175 and take 245 as the solution. So B. And that does it for this review sheet for the third test. So thank you for watching, and if you're in the class right now, study, 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 rework this review sheet, or work it yourself if you, hopefully you've been working it with me. Thank you for watching. Bye-bye.